just only keep the, okay, try number two. Okay, so today I'd like to do testing. Okay, so this is chapter 8. So we're actually moving pretty at a good pace through this book. And chapter 8 is all about testing. Okay, so first thing we discuss is what is, there's two different types of tests. One is regression testing, and um, anybody heard of smoke testing? Do you know what a smoke test is? What?
So like the one in your cabin,
The what?
the smoke sensor in your kitchen.
During,
Well, like when you're doing the pan fry things, there's a lot of smoke that's gonna be alerting the whole building.
yeah, but what is that for in software engineering, right? So there's something called the smoke test, which basically means that there's something going on, like you said. Like you see smoke, you know there's a fire. So a smoke test is like the minimum test you could run. So basically a smoke test is like if you click on the icon, does a program start up? Okay. So it's a minimum test just to see if the program starts, for example, right? Just for example, just to see if the program will start. Okay, so that would be a smoke test. A regression test is that is where the regression test is more that you okay. So what does regression mean? I think we might have mentioned this in chapter 3, but we'll just go over it again. Do you remember what a regression means? To regress in English means very good. And what's regression testing?
You're testing
I'm sorry?
backward.
Well, you're making sure the program didn't go backwards. And how does a program go backwards? It's basically you're testing a previously found bug, and you're making sure that it doesn't come back. Right. So, no, it's basically every time you fix something, you write a test for it, and then you keep on testing it. And somebody just joined. Okay. So, um, okay, so that's a smoke test. Okay, you're just doing a little bit of a test just to see, right? Regression is to make sure that bugs in software that were fixed um, do not reappear, not reappear. That would be the opposite of what we're trying to do. So it would be do not reappear. Okay, and we check to make sure bug is not returned by continually running the same test, usually using automated testing for it. Right. Obviously, we're not going to pay somebody to do this over and over again. You obviously want to do this with a automated test. Okay. So, okay, now there's something called test-driven development, which again we discussed TDD, which we discussed in chapter 3, right? So this is actually this is a way that this guy Robert Martin, who's like he's like one of the gurus of object-oriented programming. So he basically um, this is what he came up with. So to show you what it's very interesting the way he does it. Okay, so we'll spend a little time on that. Okay, what?
Well, once you get a moment, I think I uploaded it.
Okay, so we'll do it a little bit, just want to do some class. Okay, good, great. Okay, um, so just please,
JUnit test here called stack test.
why is that?
I'm going to write a test inside it, which I call nothing.
Oh,
This allows me to wire up
wait a
chain
second.
into the project.
Oh,
Good. And now I should be able to run this test.
You can't hear it? Oh, I know.
It all passes. I'm pro.
Okay. Wait a minute.
Mine, nothing.
Okay, so let me just fix the audio. Uh, audio, select a same as probably this one, right? Select same as system. Try this one.
Thing test works. The
Didn't
first
work.
thing I do with every
Wait a minute.
project, every project begins the same way.
Hold on. I think that it's on. Let me try again. Uh, Dell. Well, I definitely don't know, so let's try that.
Because now I have an execution environment. Now, what you and I are going to write is the class stack. A stack is a first in, last out
Here.
data structure.
Okay.
First
So could you see this?
in, last in the
It's very interesting way it's
It's going
gonna
to be
do.
a stack, nothing but integers. I'm not going to.
Here.
It's going to be a stack of integers.
You can see it.
We will begin with a stack test. You can see I've created a JUnit test here called stack test. I'm going to write a test inside it, which I call nothing. This allows me to wire up JUnit into the project. Good. And now I should be able to run this test. It all passed. I'm the program. My nothing test works. The first thing I do with every project begins the same way because now I have an execution environment. Now, what you and I are going to write is the class stack. A stack is a first in, last out.
So he's gonna do like a stack, right? If you watch this whole video, you'll see how he creates a stack. But he's gonna do it using test-driven development, okay? So
That's basically to write. The
what?
test. That basically means to write the test first, right?
Right, yeah, but he shows right, he gives it right. Just he'll give an example.
First thing you push in, last thing.
Could you see it, the screen?
It's going to be a stack of nothing but integers. I'm not going to try and put generics in this thing. Do that. I'm not going to use any kind of data structure other than an array. So we will work through the process of writing a stack. And I'll begin that by writing the very first test. Now here's the problem. What am I supposed to test? I don't have any code. What am I supposed to test? And so here's the answer to this, and this is always the answer. You already know the code you want to write. If you weren't doing test-driven development, you know exactly what you'd write. You'd write public class stack. Okay, so you just have to write the test that's going to force you to write the code you already know you want to write. This is always the rule. You write the test that forces you to write the code you already know you want to run. I already know I want to write public class stack, so what test do I have to write in order to force myself to write public class stack? Create the stack, yeah. So, okay, fine, I'll change the name of this to create stack. That will not be the name of this test in the end. It's a reasonable name for the moment. Okay, I want to create a stack. Yeah, okay, what should I call this stack? My stack, I'll call it my stack. Stack equals new my stack. Oh, heavens, look at all the red. That red, that means it doesn't compile. I violated one of the laws. I gotta stop. And see if I can create the stack. Okay, I'll have the IDE create the stack for me. Create class stack. Yeah, I hit the stack. There it is. Oh, good. Oh, it all compiles. And I'll bet it even runs. I'm a programmer already. I got that to work. Now I can refactor. I wrote a little test. I got it to pass. I can refactor this. There's really only one refactor I want to do. I don't want this to be called my stack. I want it to be called stack. I call it my stack because there's another class in the Java library called stack. If I call it this stack, and we can rely with it until I have established it in a package named stack. And then does this still pass? Oh, yes, it does. Good. Okay. Now, notice that I'm not asserting anything. That's a bit puzzling. What should I assert about a brand new stack? It's empty. Yeah, okay, fine. So let's assert true that stack dot is empty. No, it happens, it doesn't compile. Let's see, assert true doesn't compile. Why? Well, because you have to call that on the assert class. Okay, whoa, that's not linked in. Okay, let's look in the assert class. The word J, okay. And oh heavens, I don't have is empty function. All right, so I guess I'll have to create is empty. All right, good. Let's see, it should return false. That'll make it fail. That's a good thing. Let's see if it fails. Yes, it fails. Good. Now I need to make it pass, and I can do that by returning true. Programmer. Now I want to refactor a little bit. Now, by the way, people don't like what I just did. Lots of people look at that and go, that's stupid. Why did you return it true there? That's not the real code that goes there. My answer is, well, yeah, that's true. I've just tested my test. I've seen my test both pass and fail. It took me no time at all. Why wouldn't I do? So, of course I'm going to do that. A little bit of refactoring. I can get rid of that assert dot by doing a static import, I think. That should still work. Yep, good. Okay. Oh, I should change the name of this test. Okay. What should the test be called? Empty stack. Oh no, new stack is empty. Good. Perfect. Okay, makes sense.
Okay, so okay, so
What should I call it? Push. Good. I'll change the name there. Oh, I need stack. Stack equals new stack. Oh, heavens, I've got duplicate code there. Look at that. I've already got that line there. Now I've got it here. I'm going to have to refactor that. But not yet, because I don't have a passing test. Can't refactor until you have a passing test. All right, I need to push. Push. What should I push? 0. I'll push it 0. All right. Ooh, there is no push function. Look at that. It's red. All right, I'm going to create a push function. Do that. Oh, good. Yes. All right. Void. Yes. Return void. I know. Oh. I don't need it. Good. What should I assert here? Should not be empty. Good. All right. Assert false. Stack dot is empty. That's good. Okay. I don't have an assert false, so let's see if I can get that. It should be in the assert class, and we know that. Okay. Oh yeah, that seems to work. Now I should be able to do the stack anymore. This should, I'm not sure. Oh, it failed. Yeah, it failed. Right, okay. Because now it should not be empty. Okay, how do I make this pass? Well, I can't return a true there anymore. Yeah, I can try that. Right? If I can type false, right? But I think that's going to fail the other test. Yeah, I failed the other test. So now I'm going to have to actually engage 1 or 2 brain cells here. Now, one of the rules of test-driven development is that you engage as few brain cells as possible because you're going to need them later. Right? So don't do too much too fast. Okay, I'm going to have to do something here now. And I think what I'm going to do is take that false and I'll turn it into a field of the class called is empty. Okay, so now it's a field of the class. That's good. And I should probably initialize it here to be true because it starts out as empty. I don't need this assignment statement there. I don't know how that got there. I think that was the original initialization. And now when I do a push, I should say is empty equals false. Oh, yes. Now there's already people in the room like this. What kind of gunk is that? Hold on. It's going to get more frustrating soon. I've got some duplicate code here. I need to deal with this duplicate code. And the duplicate code is here and here. And I can deal with that by extracting the stack variable into a field of the class, initialized in the setup method, which my IDE will happily define. So now I have a not stack, heavens. Okay, there's my field of the test that holds the stack. I've got a setup function that creates the stack, that's nice. I have my new stack is empty function, which asserts that the stack is empty without bothering to create it, that's nice. And now I can eliminate that creation from that test. I think that'll pass, does. Now I can change the name of this test to after one push is not empty. Okay. And I think that's still pass. Okay. Next test case.
Okay, so basically what he's trying to do is, oh, I'm sorry, I did the wrong.
So the way these tests run in JUnit is an instance
Sorry
of the
about
stack test class
Um,
being created.
I
The
gotta
setup function will be called,
find the,
and then the first test function will be called.
there it is, hold on.
Then another instance of the stack test function will be created.
Where
The
is,
setup function will be called, and then the next test function.
okay,
Is that the question?
okay, so, okay, could you see my screen? Yeah, okay, so basically, his idea is like this. His idea is you do what's called red light, which is you create the test, right? Green light, which is you make it pass, right? Right, which is the way you like, for example, he created the test that did the object and then he and then he ran it, right? I'm sorry, then he created the actual object, right? And then again he did with the is empty, right? And then when he did the push, right? So first he wrote the code and then he made it work. Okay. And he did as little as possible just to make it work. Right. And then after each round, he did what's called refactoring. So what he does is he goes through all these loops of red light, green light, refactor, right? So first you fails, right? The test fails, then it passes, then you fix up clean up the code. That's why he's always like after each test, he renames it or he moves stuff around, right? So he's constantly fixing up the code as he goes to keep it clean. Okay?
So when he makes the test pass, like he did it with one, he didn't actually write the code, he just wrote like return true.
Initially he did that, right? But then eventually he had to change that because, right.
So he's just testing the test against itself, like that.
Well, no, he's just making a pass, right? Right. He's saying that, well, the way I mean, it's a little bit strange, but if you follow this video in about 20 minutes, he's going to write a really nice class. It gets really complicated. Like right now, it's really simple, but if you keep on watching it, you'll see it pretty soon. He comes up with a really nice stack thing, but it's just interesting the way he keeps on building on it. Yeah. So I don't want to spend, I'm going to give you the link if you want to watch it yourself. But that's his idea. And it's a pretty, I don't know anybody who does it. He actually suggests you should do it on two monitors. So you just go back and forth. But, you have the unit test on one monitor and the compiler, you write the code on the other monitor, and then you go back and forth. So it's really fast. No, he doesn't want you to spend, a long time running these tests, right? Right, just maybe a minute for each test. But the idea is that you could just go back and forth, and eventually you end up with a big object, but it's all been tested every step. So, I mean, you'll see it. You'll see it's pretty interesting. It gets like at about 15. I don't know if I watch it till then, but like after maybe like 20 minutes, it gets pretty complicated. He has a more complicated object. Okay, let me just turn the light. About 15 minutes, you do your presentation, okay? Okay, so, so what is the advantage or of you having unit tests? Well, one of the advantages is you notice that also like on the project, you're supposed to have a assert, right? What's the point of an assert? Assert true or assert false? What's the purpose of that? Yeah, but why? What?
It's a test.
Yeah, but why? But why specifically assert, right? Because the idea is it could be run automatically, right? So in other words, you don't need anybody there to check to see the results to see if it worked or not. Right? If you have an assert, it's always, if it fails, it's always gonna, show this test failed, right? So even if it runs 1, 2, and 3 in the morning, right? Your server could, because you could say at 3 in the morning, you could schedule all the unit tests to run. Let's say they take a while to run. So you could say you could schedule from 3 a.m. to 5 a.m. and you could see if they, you know, you could test thousands of them, right? Hundreds of them at a time. And they're always gonna be either true or false. So they're either gonna pass or fail, right? And you'll get a report the next morning of what happened, right? So that's the beauty of a unit test, right? Is that it can be automated, right? No human intervention. That's why I was very, insistent in the project that we do asserts, right? Okay, because that's because there's no one's going to sit around, manually going through all the automated tests, right? You can have hundreds of them, thousands of them. So, especially the way he writes it, right? You can have like a lot of them. So, how do you make sure they all work? Okay. Also, I explained also. Actually, two is a real explanation of. Oh, no, no. Actually, one is different. One is that since they're automated, they can be automated. Every time you theoretically, every time you check in code, you could have like your pipeline besides building the code. Your pipeline could actually and deploying the code could actually run all the unit tests on it, right? So before it actually builds the program, so it'll make sure it passes everything before. So theoretically you could do that. I mean, my unit tests at work, they uh, they take too long. Yeah, if you'd have 100 of them, it would take an hour or two. But so, but theoretically you could do it, right? Um, if they're quick, if they're quick unit tests. Okay. Three, it's considered to be part of development. So what that means is that um, um, okay, so what that means is that you remember like with uh, um, the Scrum programming, right? With um, the incremental, right, programming. So, so you remember that we had three parts, right? We had design, code, and test. Well, when we talk about unit tests, they don't go with the bottom in the test because that test portion, right? You remember, right, that's when I just show it. So, like for example, um, incremental. So, so like if we, where is our diagram? No, that's not it. Sorry. Uh, uh, incremental programming, uh, model diagram. Okay. Yeah. So like over here, I have to change my glasses. Okay. So, oh yeah, so if we look over here, right, when it says testing, actually okay, maybe it's written, this is using what, I think it's written backwards, but the way we taught it was you do design, then the blue, and then the red, right? First you design it, you implement it, and then you do testing. So, but is, the unit test is part of the blue, the coding, not part of the red. Because the red, the way we did it in chapter 3 is a testing group. It's a separate group. Well, usually that does testing, right? And the people who write the code, they write the unit test, right? And we just saw exactly why, because they're supposed to do it before they write the code, right? Yeah, or even if they don't, even if they write afterwards, but the point is that they're doing their own testing before they give it to other people to use, right? So that's the idea of so whenever you see testing on a diagram, it does not refer to unit testing, because unit testing is always going to be part of development, right? So if you have a job and you write code, you don't have to say, well, I wrote some tests, because that's part of the development, right? It's not like a separate thing. It's considered to be part of it, unless your boss gets angry at you if you do that. But I don't know why they would. Um, so that's number 3. Number 4, the idea, okay, if you do it before coding, the object is that if you write the unit test first, this is besides the way he just explained it, but just a simple understanding of it is that if you have to write a test, that means you have to think about something before you write it. And after you write something, you probably are going to say, oh, it works already. So the best time to write a test is before you actually write the code, right? Because after you write the code, you say, oh, it looks like it works. And you just say it works and that's it, right? So um, it's actually one thing I like about AI is that where I just started using it at work, but one thing I like about it is that I tell it, write some unit tests for this class, but I don't tell it which ones to write. So in a way, so I give it the ability to try to, come up with their own test. Because if I write the unit test, they're always going to pass, right? Right? Because I was thinking about it a certain way, and that's how I wrote it. So it's better if someone else, like the AI, would write it. So that, let them think of maybe, and they do, and also they're less lazy, so they'll they don't, they get more money the more tokens, whatever they use up. So they'll create more unit tests than I would by myself, right? So sometimes it goes a little bit crazy, but yeah, but so far, yeah, I find it very good for like unit testing, because like no one wants to write a unit test, so if I have them write it, at least they you know they made it a lot more efficient. Okay. Um, okay. And the benefit, okay, again, is that it's good for the company, right? Also, um, right? So, because now the company's going to have all these free tests that run, right? They don't have to pay anybody anymore to test it. They don't have to hire, right? Because you just run them automatically, right? You don't need unit tests. Um, Another thing about right, unit tests are usually on one little object, so they usually don't break, right? It's kind of hard for them to break, because they're usually just testing a little thing, right? One object usually, right? Um, they also give feedback right away before you right that it's working, and it gives us confidence that when we change something, that if the unit tests we wrote yesterday still work today after we made our change, then we feel a little bit better. Okay, that maybe we didn't destroy the program, right? Um, And unit automate um, oh yeah, and the last thing we said sort of before is that they're automated, meaning that you could put it into the pipeline. Okay. Um, okay. So before we start this, you want to give your presentation? What's your name again? What?
Science.
I'm sorry? Science? Sci? Okay. Sorry. Let's see if I can find your. So we have a quick presentation. 5 minutes, right?
Yeah.
Okay. Uh, where is it? Here we are. And where you uploaded it? Oh, okay. Here we go. Yeah. This
Yeah.
critical path?
Mhm.
Okay, great.
Okay, so hi, my name is Sayantan Saha, and my topic was on the critical path. So this presentation, I'll be going over what it is, how you find it, and so effectively, the critical path is like it's a concept used in project management, where you find the shortest path to be able to complete a project. So yeah, what is it? You find the longest sequence of tasks within a project, and that should be your critical path. And in doing so, you're able to determine your total project time, as well as you're able to determine, uh, well, okay, you're not able to determine, but if there are delays, then you know that there will be a delay in the overall project.
Was it the longest sequence or the shortest?
It's the longest sequence of tasks that is the critical path because that becomes the minimum time it takes to complete the project. I'll go into it in a second here. So the key idea here is that critical doesn't necessarily mean the most important task. It means the most time critical. Basically, you could have a crucial task that is required for the project's like success, but that isn't necessarily included in the critical path because what we're looking for is those tasks that are most time critical. So if it takes longer, then the project will effectively end later. So now I have here, we can break down how to find it into 4 basic steps. So the first of these steps, you want to list out all the tasks that are in an actual project, regardless of any other metric, just all the tasks. And then you want to find link dependencies between these tasks, sorry. And in this context, a dependency is basically a task or a task that must be completed before another task. So you're looking for what comes first, the order. And then certain tasks can occur at the same time. You do them at the same time. And because of that, it can branch off into multiple paths. So that leads into our third step over here, where we calculate the durations, how long each of these possible paths might take. And then using the durations we've calculated, we have our fourth and final step. We identify the longest chain. So the longest sequence of those tasks, that path is your critical path. Oh, and I should note that this is the core design of the critical path. In order to do the individual steps here, like list all the tasks and calculate the durations, you have separate tooling such as WS, which helps to list all the tasks, and then PERT, which helps to calculate the durations. But those are beyond the scope of this presentation. I just thought it should be mentioned. There's WD, there's a couple. There's forward, backward pass, WBS, which is for listing all the tasks, and then PERT, which is a formula to calculate the duration for the paths. It's beyond the scope of the presentation, but I believed it should be mentioned. So I wanted to help us understand the critical path using a quick example here. So here we have this chart where we have step 1 already done. We have all the tasks written out for us, A, B, C, and D. As we can see, design, materials, build, and test. So now if we move on to step 2, we have to determine the link dependencies here. So we know that A and B must occur before C because you must design and have your materials before you're able to build. And then C must occur before D because you must have your build before you're able to test it. So if you remember how I mentioned a little earlier, we have certain tasks that can occur at the same time. Well, A and B here, design and materials, can occur at the same time. So they can branch off into two separate paths. So your path as of now looks something like A and B into C into D. And on this next slide here, you can see the two actual paths. So A to C to D and B to C to D. And we can move on to step 3, which was to calculate the durations of these paths. So using the times that we had earlier, you find that path 1 takes 9 days, and then path 2 takes 10 days. And since path 2 takes longer, we can determine that the bottleneck is in path 1, and it is task A.
Well, with that, path one,
Task 1.
yeah, path one.
Yeah.
Is A, B, C, D, or
A to C to D.
A, C, D, D?
Yeah. And then path 2 is B to C to D.
Oh, right, okay.
And then, so,
But
All right.
doesn't A have to, you can't go to C until you do both B and,
yeah, both of these paths occur at the same time. But if you think like you can think about it literally like how the diagram shows here. These both occur at the same time,
Oh, I see.
but this one ends in 9 days and this one ends in 10
Right.
days. So you're looking for the sequence that takes the longest because
Right.
that is the
Okay.
minimum length.
yeah, I got it, okay.
So now our result, B to C to D is our critical path. And we can see that the total time it takes is 10 days. Now, given that 10 days is a minimum, because should any of those individual tasks in the critical path, B to C to D, have a delay, then the entire project will be delayed somewhat. And task A, since it's not in the critical path, but it is still in the project, we can say it has slack. Slack effectively means that this X task can be delayed a certain amount of time without having negative effects towards the project. So in this case, task A can be delayed by 1 day and nothing bad will happen because you'll still be on the same sequence as we see here.
Mhm.
So to conclude, the critical path is basically used to predict finish dates and effectively control the timeline of a project. And we can also use it to assign resources effectively where we see tasks that have the greatest time concerns. And overall, it helps to manage project risk. So we can say that we are focusing our energy where the clock is ticking loudest. Thank you.
Okay, very good, wow, very good. Oh, sorry. Okay. Okay, back to chapter 8. Okay. Okay. Okay, so back to chapter 8 and close that. Okay, but now we're really getting to this chapter. So basically the chapter mentions, and you could look at it, but basically I sort of like just took out the parts I thought were important. This is so basically there's 5 stages, right? It's a little bit confusing if you look at the chapters, but this is what I got from it, is that there's 5 stages of testing. Of course, every company is different, so could be 10, we're in your company, or you can make more or less of them. But basically there's 5. So number 1 would be the development testing, which is what we call the unit testing, right? Which would be the lowest level of testing. Then, which which is really considered development. Then we have component testing, where we're testing or they, I think it might also be called integration testing. I think it's called integration testing. Well, because any after the first one, I think this. Okay, you might see it used as integration testing. And the reason why it's called integration, because you're you're testing how things work together, right? Now, you're in step number one, you're only doing testing the one object, but how they work together, right? That's the component testing, and then system testing is where obviously you test the whole shebang together, right? So we go from just testing one object to number three, which is testing the whole system, right? And then component testing would be like somewhere in the middle, right? Where you're testing how things work together, but it would how they integrate with each other, but right, okay. So and then finally, so the first three steps are really just to see it doesn't blow up, right? In other words, we're really not trying, um, we're not concentrating on the features so much as just getting it to work. Okay. It's in other words, like it's not like we're not like looking at the specs. We are looking at the specs, but we're not like concentrating on it. In the release testing, that's actually where we say, okay, we have a stable program. Now, does it do what we promised it would do? Right? And that's the reason why it's done by a non-member of the programmer team. So you need somebody else who's not a member of the development team, usually, well, which is usually okay because you usually have a testing group, right? And they going to do the release testing, and their focus is not does a crash because that theoretically we already fixed all those issues, right? And they're just making sure that it does what it's supposed to do, right? Does it live up to all everything we initially said our program's going to do, right? They'll go through all the stories and see that everything is there. And then finally, the last step is you give it to the user and let the user look at it and let them test it and see if it makes them happy, right? So I used to work at a small company, and actually, we used to the way we did our release testing was we used to like somebody would ask us for like a feature, and we'd say, okay, we'll give you the feature, but you're going to be our guinea pig, and then if it works, we'll give it to everybody else. Well, we didn't tell them that part. We just said, okay, we'll give it to you, but you realize you're going to be the guinea pig because no one else has this feature. So we give them a new version, and then they would use it. And then if they didn't complain after a while, we would give it to everybody else. Because it was a small company. We didn't really have anybody to do real testing. So just had like three programmers, and the owner of the company used to be basically you know, the main tester, I guess. He would look at it. So we didn't really have that much, of that much staff to test. So that's how we did it. Okay. Where I work now, we have a bigger, I think, as far as I know, one full-time tester, maybe even more that I don't know about. But we at least have one full-time tester. So, so that person would be able to do the release testing. Okay. Okay, so that's it. Then I'm just going to go through some of the stuff from the book, which is that, again, I was saying before, the development testing is we're looking mostly for bugs, right? We want to make sure the program is stable. Um, and then in the book, it mentions two types of testing that you could do in the in development or maybe even integration testing. So they're called partition testing and guideline testing, right? So what are these? So partition testing basically means that what you're doing is you're checking the edge conditions, meaning like, for example, let's say you know that let's say you have a method that adds two numbers together, 1 and 2, right? So if 1 and 2 is going to be equal to 3, right? So is there any point of checking to see if 1 and 3 is equal to 4? Where would that be a valid unit? Right, that'd be a waste of your time, right? What would you look for? You look for something like this over here, where you'd give huge numbers and you would see what happens, right? With that, or you negative numbers or something like that, right? Or null, or something that might actually break it, right? So you don't just do 1 + 2, 1 + 3, 1 + 4, 1 + 5, because that's like wasting your time, right? So you have an example over here of edge testing would be, let's say, for example, the expected input, let's say it's a social security number, right? So I think a social security number has 10 digits. Let, I don't know, let's say, whatever it is, you're expecting something, let's say a zip code, something between 4 and 10 digits, right? Or characters. So your edge case would be where there's only 3 characters, or there's 11 characters, right? Those are the cases where it's going to fail, right? Where it should fail. And you want to see how your program's going to handle those edge cases, right? So that, but where it's 4 characters or 10 characters, then it should work, right? So you want to write 5 tests altogether. Really, you just need 4 tests, meaning you test 3 characters and 11, make sure that it fails in those conditions. Then you would make sure 4 and 10 pass, right? And then you do one in the middle just for the fun of it, right? The one in the middle you really don't have to do because there's no reason to think if 4 and 10 work, there's no reason to think that 7 characters is going to fail, right? But why not? We'll just do one in the middle. Okay. So they give the same another example over here. This is from the book. So this is one type of testing. So basically we're testing the edge cases, right? Where we expect, let's say for last name we're expecting at least 1 character, and you do blank, we expect it to fail, right? Let's say if you need to enter your street address and you put blank in there, or email address should have at least maybe an @ sign and a dot, right? Or something like that. So, the certain minimum you expect for like an email address or a phone number, right? A phone number should have at least 10, well, at least, I don't know, international, but it should have at least, let's say 6 numbers, right? So that would be your edge cases, right? Or let's say a phone number cannot have more than, let's say, 20 digits, right? Um, so that would be your edge conditions. Now, guideline-based testing is basically testing where not that so much as the edge case, but rather you give it input that from experience will stress the system. So, for example, let's say you create a website, you hit it with 1,000 web browsers. You have like AI, or you have these bots. You know, try to access your website at the same time. 1,000 of them at one time. They're all trying to get your website and see what happens to your server. Does it crash? How does it respond? Right. So that's not really an edge condition. It's more like, from past experience that if you give a lot of something or nothing of something, right, that tends to crash, right? So it makes things crash, right? So, for example, if I would ask you, test google.com, right? Well, what would you do? How would you try to make? So the only thing I could really think of is to maybe do HTML injection, which I don't know that well, or maybe you would just like um, go to Google and maybe give it how would you try to crash Google? Well, I'm sure now it's been tested pretty well over the years, but like I would think maybe you give it uh maybe like a huge file or something like that, something or a huge amount of text, you know, and then you just see if that'll crash it, like maybe cut and paste from this whole document and put this into Google and see, because from experience, you know that when you put in yes, it didn't crash it. Okay. Hey, whoa, where'd they get that from? Huh? They got it from me? Uh, oh my gosh. This is my own, it made an AI overview of my own, what I just pasted in. Okay, pretty cool. So anyhow, but it didn't crash it, right? I put in my whole document and it failed to crash it. And it even gave me a nice AI. It actually wasn't so accurate, skipped a lot of stuff, but it gave me an overview, right? So that's guideline-based testing. Or my favorite is how do you always crash a method? Let's say a method takes an object. How would you crash it?
If it's something that's not the object it takes,
That's what?
say it takes an integer, you can give it a float,
Oh, well, but then it won't compile maybe.
other return crash.
What?
Oh, no, it's
And then let's say you have a program you want to try to crash it. So like I always do is pass it null, right? And it's very interesting, or divide by zero. That's always a good way, right? That's a good way to crash something, right? Like if you have a divide method, put zero in there, see what happens, right? Now, I happen to notice that Java is very hard to crash. I think if you do divide by zero, it catches it. If you do null to a method, it catches it. I've tried it. So it's not so easy to crash. Okay. I mean, it might give you an error. I mean, it won't crash. It might give you a message, but it won't like, stop working. It's very, okay. And then this is also from the book is there's something called black box testing and white box testing. So black box testing means more that, like, for example, somebody in your testing group, that would be like black box, right? Like, for example, we were just testing Google, right? We were doing black box testing because we don't know how it's written, right? So, so for us, it's a black box, right? So we're just throwing things at it, right? Which is actually probably better if we don't know how it works. So then we'll think of things that are innovative ways of testing it. White box testing, on the other hand, means that you know how it's written and that you could sort of figure how to make it fail, right? So they both have their advantages and disadvantages, right? So if you're white box testing, then you might have an insight how to make it crash, but you might not, but if you know how it's written, you might think the way that the person who wrote the code thinks, and then you're not going to think how people in the real world are going to use it, right? Like if you like, if you ever if you see children play with things, they never use it the way they're supposed to, right? Right? If you give them a toy, they'll throw it at the wall, right? Yeah, they'll see what happens when you throw it at the wall, right? They're not going to play with it necessarily, right? So, so just because you think it should be used a certain way, doesn't mean that's the way it's going to be used, right? Um, and then basically, I just said, basically, this is all repeating what we said before. Um, the book is very wordy, and I just tried to get rid of. And then anyhow, so then so that's basically what we said. And then in user testing, they mention three types of testing. There's alpha testing, like if you ever heard of, they come up with alpha and beta, usually beta testing, you don't hear so much about alpha. It's basically like my company used to like give like one company to test a new feature that they wanted, right? So that would be like basically like alpha or beta testing, right? We would just give it to certain people. By the way, why would someone want something before it's finished? Anybody know that? Who'd be interested? Like, why would I want, let's say, like, what?
Play the game before other people, then
Oh, I didn't think of that.
the
Okay. You mean they want to see it before it gets out? Right, but but like, let's say Microsoft Word. Why would someone want to get it before everyone else? Why would they want to be a beta tester? Like, why would I want to waste my time, like running software that might be buggy? Let someone else waste their time, right? Like what? Yeah, like, well, one thing is we mentioned, it might have a new feature that I need, right? But right? There's another reason though, which is that a lot of times people integrate with your software. So for example, Microsoft Word might have other products that work with it. So the other companies that work with it, they want as soon as possible to get before it gets released, they want their latest version of their software to work with that product. So for example, let's say you have Visual Studio, Visual, what's it called? Visual, Microsoft Code. What's it called? Visual Code? What's it called? Yeah, Visual Studio Code. Right. So, for example, Claude, AI Claude integrates with it. They have an extension. So, if they come up with new Visual Studio code, they want to make sure that whoever writes extensions for it wants to make sure the extension still works, right? So they want the beta versions, right? Because they don't want to wait till it comes out. Because when it comes out, then they don't want there to be like 2 months where their product stops working, right? They want to be able to say, oh yeah, our product works with this release, and this release, right? So, um, so that would be it, and that's basically it. And then this is it, the summary of the chapter. Okay, so we finished pretty much the chapter 8. Okay, um, Thursday we're gonna do writing code that's writing testable code. Okay, how to write code so it's easy to test. Okay, so it'll be a little bit of a different thing than we're doing today. Okay, today was more like bookish. Next week we'll do more like trying to look at some code and see if we can make it easier to test. Okay, so see you on Thursday. Okay, have a good night. Okay, see you.